Okay, perfect. So hello everyone, I am Sadik from Datamax. I am co-CEO and working as a senior machine learning engineer there. Let me try and get this away. Right. Yeah, at Datamax we help our customers not fail into their machine learning endeavors, help move the machine learning workloads into production as soon as possible and as safely and efficiently as possible. A few words about myself. I've been working in data and information system management in the last 10 years, started with normal OLTP databases and then moved more towards analytics with OLAP databases and then with Spark, machine learning and cloud. Quick agenda for today. First is why do we need orchestration? Then I'll be talking a bit about the tools and concepts that will be used. Then the question is how do we run Spark on Kubernetes, and then how do we add more layers? How do we run Spark on Kubeflow on Kubernetes? Then it will be a short hands-on demo. Right, let's get started. First is there are three major steps into making a machine learning pipeline work. First, we have the pre-processing, where all the data is prepared, cleaned, formats are changed, features are calculated. Then we have the training stage. Here, one or more models is trained. And then in the serving stage, the trained model from stage 2 are made available to the users, to the business stakeholders, or to whomever is our target group to provide predictions. And then the data coming from the predictions in the serving stage is then fed back into the loop to make our machine learning models more accurate and to keep them up to date, since the initial training data might be getting old quite soon. Of course, in theory, this is it, but in practice, there are many more stages here. We have to do some model evaluation, model monitoring, feature engineering, and so on and so forth. But let's keep it simple for today. In our talk, we will focus on the pre-processing stage here, where all the data is processed and hopefully made available for the training. The problem now with machine learning workloads is that the input data that is available is growing exponentially. And at this point, it becomes difficult to process this data and at the same time to efficiently manage all the resources or efficiently use all our resources available. Of course, before we could buy a bigger, better machine to do more processing, but now this is not always the case. It will either get too expensive or it's not possible anymore. So for that, we need distribution. We need to be able to distribute the workload. So instead of scaling up, we need to scale horizontally. However, with distribution, it means that we have a lot of resources available, and then we are using these resources to do the workload. But we need to manage all these resources efficiently. And that's why we need orchestration. For orchestration, our workloads sometimes are composed of multiple steps. Some steps are dependent on the output of the previous step, so they have to be executed sequentially. Some other steps, like in here, are not dependent on one another, so they can be executed in parallel. So the orchestration helps us finish our pipeline as soon as possible, use our resources as efficiently as possible, and then if we are in a cloud environment, you can get rid of these resources at the moment you don't need them anymore and not pay for them. However, this is not enough. We need also integration. Integration means that the data processing workloads should be running on the same infrastructure where all the other workloads are running. Failing to do so will introduce data silos. A data silo is when a group has access to one collection of data while other groups cannot access this data easily. And this makes it difficult for the whole organization to have a common view or to be able to access all the resources available. Therefore, we should aim to always have most of our workloads running on a common infrastructure. This comes with a nice side effect of saving cost and time, because you don't need to maintain and deploy a separate infrastructure with separate teams and all the complexity that comes with it. By default, in most of the organizations nowadays are running their workloads in Kubernetes, and the data workloads should only be one of them. For the distribution framework, I'll be focusing on Spark today. There are other alternatives like Dask, Ray, and so on. But first, let's do some, let's explain some tools and concepts that we will talk about so that we are all on the same page. First, Spark. Spark is a distributed computing framework used widely for processing large volumes of data. It basically distributes the workload to a set of nodes called executors, and then once the processing is done, distributed on each node, and the results are collected in one node that is called the driver. Of course, I will not go deep today in how Spark works, but if somebody is interested, I encourage you to go through the official documentation. As was mentioned also in the talk by Peter, Kubernetes is a container orchestration framework, is by default standard used in most of the companies nowadays. It's portable, extensible, and very flexible. In our context, a Kubernetes workload is one processing step, but it can be anything. It can be a database running, it can be two services running, and so on and so forth. Like in Spark, Kubernetes has a control plane that controls everything, makes sure that all the workloads are running, also distributes the workloads to the particular nodes, and takes care of all the configurations. Now that we know something about Spark and Kubernetes, the question is, how can we run Spark on Kubernetes? There are two main possibilities here. We can either use the Spark submit command, which uses the Spark native Kubernetes scheduler, or we can use Spark operator. Spark operator is an open source tool that you can use to make deployment of Spark applications as very easy to deploy in Kubernetes using the normal way how workloads are defined on Kubernetes. Mainly, it means that you define a manifest file, usually a YAML file, and then apply a kubectl command that will tell the Kubernetes cluster, please execute my Spark job. And then based on the definitions, on the custom resource definitions that are defined by the operator, Kubernetes knows how to execute the workload. It will spin up the driver pod, it will spin up the executors, and then set up also the communication between these nodes. In the demo later on, I'll be showing how to install the operator and how to use the operator as well. Yeah, the next stage in this discussion would be Kubeflow. Jimmy described it very well. What Kubeflow is, it's basically a platform that makes easy to run machine learning workflows on Kubernetes. All the components that I have shown here are only a small set. Jimmy went through all of them as well. However, we will be focusing a bit more in the pipelines today. Of course, the pipelines is composed of components, and these components have dependencies or relations with one another, and then the pipeline defines all these relations in a graph. Once one of the components is finished, then the pipeline takes care of triggering and executing the following steps. What is a component? Is a pre-processing step, is a transformation step. It can also be a model training step. It can be anything or almost anything. Usually the components are defined as containers or manifest files. For Kubeflow to know how to execute a component, we need to define a component specification. The component specification tells bridges between Kubeflow and Kubernetes how to execute this component. There are, of course, we don't need to write our own specifications for everything. There are a lot of specifications and component specifications defined in the Kubeflow pipelines repo. There are such for AWS, for GCP, for Azure, for PyTorch, and as well for Kubernetes. Now the question is, how do we run a Spark job from Kubeflow pipelines in our Kubernetes cluster? And the answer is we use Kubernetes components. First, we start with the apply component. The apply component basically loads a manifest file and then triggers the kubectl apply command with this manifest file against our Kubernetes cluster. This is in our case would be the Spark job manifest file, and Kubernetes gets the information and it starts running the Spark job. Then we'd use the Kubernetes get component. The get component for a Spark job would be checking what's the status of the job. Is it still running? Is it completed? Is it failed? And we'll get this information from the cluster and then decide what to do with it. If it's running, then it will do another iteration. If it's finished, then it will move on to the next stage. That would be it in the theory part of the presentation. Next up, I'll be showing you how we can run a Spark job using Kubeflow. Our Spark job is going to do an approximate calculation of pi. This is one of the example jobs provided in Spark distribution. I'll stop sharing my slides and move to the browser. So here I have the Kubeflow pipelines deployed in the cluster. We can see how to do this. There is one GitHub repo that explains all the steps. It has also one makefile where you can deploy everything from scratch. First, we start by creating a Kubernetes cluster. In my case, I'm using Minikube locally, but you can use any Kubernetes cluster that you want, even if it's in your cloud account or wherever. Next, we install Kubeflow pipelines. Of course, the good thing of Kubeflow is that you don't need to install all the components. You can also pick and choose which ones you need in your project. In my case, I only needed Kubeflow pipelines, so I'm installing Kubeflow pipelines. Then we install the Spark operator. To install the Spark operator, we use Helm. For those that don't know it, Helm is a package manager for Kubernetes, and installing the operator is very easy. It's just simple commands, Helm add and then Helm install. Same story also to install Kubeflow pipelines. You just need to do follow this link in the documentation and execute a couple of apply commands. Right. After installing the operator, we should have everything except for a few minor changes in the roles. We need to create a Kubernetes service account that will basically be allowed to spin up Spark applications, and also has a bit more privileges in order to be able to check the status of the application. Meaning it can check the pods if they are running, if they are not running. So here we can check what resources are we adding here. We're adding a service account in the namespace Kubeflow. We are adding a role and the role binding between the service account and the role that we just created. So that would be it. Now we can simply expose the port of the Kubeflow pipelines UI and access it. So now we should go and check our pipeline, how it works. As it was mentioned earlier, we start by loading the Spark job manifest file. The manifest file looks like very simple resource definitions in Kubernetes. It basically has a kind. This is the resource. It's a Spark application, has some name, a namespace, and proceeds with the other Spark specific definitions. Next up, we load the Kubernetes apply component. Basically, these two guys will make sure that we can run our job on our cluster. And then we trigger the operation. We do apply the command with the definition that we had. And from there, we fetch the Spark job. Of course, Kubernetes assigns a name to this job. It can be something that we define on the manifest file, but also it can be something random. So it's better that we fetch it when the thing was created. And then this would be the first step of the process. Then we need to check, is our job application still running? And for that, we have to use some special construct. This is called a graph component. A graph component is a component in the pipeline that allows us to recursively call this component. So this would be the one that allows us to iterate over in the pipeline to check what's the status. Is it done yet? Is it done yet? For that, we will load the get component, and from the get component, we fetch the application state. If the application state is not completed yet, then we do another iteration. We need to add a bit of sleep here to make sure that we are not DDoSing our Kubernetes cluster. That would be mostly it. Then once we are finished with our with checking the status of the job, then we proceed to the next step, where we are just deploying, or we are just printing a message in our case, but in your case, it can be the next step in the pipeline. So let's build the pipeline. So our pipeline was built successfully. What it does internally, it generates a YAML file, and then we can upload the pipeline. This is hopefully the one that we just generated. So pipeline. Let's put a demo here. And we can create it. So here from the graph, we can see that we start with applying the Kubernetes object, and then we have the graph component that checks the status of the object. We have the condition, and then in the end, we will print the message. Now we start the run. We have to make sure here to use our special service account. Otherwise, if we use the default service account, we might not have privileges to spin up Spark applications. So the service account name was Spark SA, and then here we hit start. We can see that the pipeline is running. If we want to check what's going on in our cluster, I've opened here the Kubernetes dashboard, and here we can see that the driver is being spun up, the operator is running. Now the driver will take care of spinning up the executors while the Kubeflow pipelines runs the steps to check if the process is finished. If we check the logs here we can see that, yeah, it's not finished yet. And in the Kubernetes, we will see that it's still ongoing. The driver is, the executors are still running. They should be finished any minute now. So here we're running a few more iterations. We're checking the status. Is it in completed state yet? Here we see that now the condition is not true anymore, it's false, and therefore we move to the next stage and we see that the job was completed. If you are curious, we can check what was the estimated value of pi. So this time it was estimated to something 3.142. If we want to make sure that our service account works, we can try and run the same pipeline again with the default service account. And here we should see some failed message. Of course, it takes a few moments until everything kicks in. And here we say that it's unable to start resources of type Spark application. So that would be it for the demo. So to summarize, here today we saw that Kubeflow, Kubernetes, Spark can be integrated together. We saw a bit what are pipelines, components, and component specifications. And we saw that pipelines can be used to increase resource utilization, can help us with automation of pipelines. Questions here. How much memory does the Spark KFP consume? This depends. It's all configurable in the resource definition. Then the next question is, did using Spark operator reduce the effort versus Spark submit? What enabled Kubeflow's ability to interact with the cluster? And for me, Spark operator was very helpful to make sure that you follow the same way or the same path how you deploy your Kubernetes workloads. If you are used to having a YAML file and then kubectl apply this, then you just follow the same pattern. While using Spark submit, you'd have to change a bit the pattern and would not follow the standard, although I don't think it's a lot more effort to do there. And the last question I can see here is how to use Spark with Kubeflow in production. Basically, I'd recommend just the same way you are using all your normal Kubernetes workflows. Just make sure that the pipelines are also version controlled, and then every time you update your pipelines, just make sure to deploy the newest version in Kubeflow. There was one issue that we had before with updating Kubeflow pipelines. There was some immutable resource. I cannot remember what was it exactly, but we went around that by, instead of using deployments, we were using Kubernetes jobs to make sure that the update was going through.